take a look at our next and our last type of graph we're going to talk about. Now, remember, let's just do a quick review on the types of graph we talked about. We talked about a line plot. We talked about a histogram. We talked about a box plot. Today, we're going to talk about line graphs. And each one of those graphs that we're going to look at in our second lesson, our next lesson, has a specific purpose and a specific job to do. So we're going to take a look and explain and take a look how that one works in our next lesson. So right now, we're going to focus on what is a line graph, how do we make it, and and what does it do? So first things first, a line graph has a specific job. Its job is to show change over time. So if you wanted to show one of the most common line graphs that you will see, and if you haven't seen already, is your growth chart. So your doctors take height and weight measurements on you every time you go to the doctor. Well, every day, every time that goes into a computer program that tells them, okay, is this child growing in the right potential? Is there a dip? Is there a change? Is there a spike? And it charts their graph over time. At this point in your life, if you're around 6th, 7th grade, they can probably give you a pretty good guess at your height for your life based on the previous information. They've got 10, 11, 12 years worth of data. They can probably tell you how tall you're going to be for at this point with a pretty good guess. So you can chart your change over time. The next thing we're going to look at now, so let's actually see what it talks about. So remember, there are 5 things all graphs must have. We need for our graphs. We need a title. I'm just going to put a list over here. We need a title. We need our labels on our axes. Okay. We need a scale. And there's 2 labels, so there's an X and a Y axis label. And as well, we also need our data plotted. So these are all the things we need. So we need to keep that in mind as we build. So with a line graph, there is a very specific order in which things go. And to be true, this is pretty true on everything. But we're going to dig into it a little more deeply. When you have X and Y data, at the beginning of the year, we talked about functions and relations, input, output. Well, with a graph, there is an input and an output. There is a way that works. And another way to say that we talked about was independent and dependent variable. Well, in this case, our independent variable is always on our x-axis. So the independent variable is time, is years. And since these graphs show change in time, your independent variable will always be your x, or always be your time. So our first thing we're going to have down here is our year. That's going to be our independent variable. That's our y. Our x, not our y. Okay? And that makes our population. I'm going to try to attempt to write sideways. Okay? And then we're going to put it in millions. Okay? So our population in millions goes down the y-axis. So I've got that. My label, and it's kind of even given to me. I don't know if you guys realize right here, these are our labels right here. They're given to me in the chart. And I'm going to put my title over here. It's Earth's population. Okay? So now I'm going to go ahead and graph. Now I've got my title, I've got my labels, I need a scale. So the bottom's pretty easy. It's giving me the information every 50 years. So I'm going to have 1750. I'm going to have 1800. I'm going to have 1850. 1900, 1950, and then finally 2000. Extend my x-axis. And then we've got a range here from up to 700, from down as low as 790 to 6,800 million. That's a huge range. So I've got a range of almost 6 billion, 5 billion. I probably can't make my number millions. I probably can't make it 10 millions or 50 millions. My scale is probably going to have to be in billions. So I'm going to go ahead and put it over here in millions. So I'm going to say 1,000. I'm going to make that a little lower. I'm afraid I'll run out of space if I don't do that. Make my scale just a little bit less. And drop it down here at 2,000, 3,000, 4,000. Excuse the poor handwriting. I'm trying to write really small. It's 5,000, 6,000. And I'm going to stop there because I can see there's 7,000 above. Now I'm going to chart my data. So 790. So it's not going to be perfect. I'm not going to exact. A little above half. 1,800, just a little higher. 1,850, a little bit above. 1,900, 116. So it's still just a little bit more. 1,950, 2.5. So we're closer to here. 20,000, we're way up here. I'm out of space. I'm going to move this real fast. We'll move our chart up and to the right a little bit so our graph can fit. And we'd be way over here. So you have a continuous crazy growth. Now, I know we have data beforehand, but you can see this massive growth right around here. we have a huge spike from 1950 to 2000, and that's really when the wars stopped happening. 1776, we've got the Revolutionary War, we've got War of 1812, we've got the Barbary Pirates, we've got Spanish-American War between 1800 and 1850, we've got Civil War in the 1850s, 1860s, well, really 1860s. Early 1900s, we have World War I. 1940s, we have World War II. And then 1950 is the last one, around Korean War, the last major wars. After 1950, you see this huge spike. As there are fewer and fewer wars, we see less and less a greater population growth because there's less and less, needless dying is the easiest way to put that. All right, your job now is to take this data for the photography club and go ahead and create your graph. And then we'll talk about how we describe the change in membership from 2008 to 2012. All right, pause the video, create your graph, and we'll go from there. All right, so I went ahead and pre-made this graph just to make it a little faster on our video. So I've got my title. The only thing I'm missing here is my title. And I'm going to add that up here at the very top. I'm going to call it Photography Club. I need to change pens. There you go. Photography Club memberships. I'm going to say Photo Club memberships just to save our time. Okay, so I've got my title. I've got my label memberships down the left, years on the bottom, 08, 09. And I probably ought to put 2000s down here on my label. And then I've got my graph. You can see you can see what's happening. Now, while we can see a pretty good growth here, we can see it here, we see that we could describe the change in membership. We would say generally it's increasing. And it's increasing by roughly similar amounts as we have a line, or pretty darn close to a straight line. You could tell me the growth of memberships dropped a little between 2009 and 2010. Overall, you're averaging roughly 5 to 6 new members every year. Okay. All right, now let's take a look at what else we can tell from a graph. So one of the other things you can talk about when you discussed its digression or its information is you're looking at a trend. When you look at change over time, you can see a trend changing. You can do that with language, you can do it with clothing, you can see different things become more popular, things drop off. We can also do that with data. Okay, so when we discuss a trend is it a general upward trend, general downward trend? Is it neutral, there's no growth? So if we look at our cost of college tuition, this is what it says over here, we're going to see it's an increasing trend. And for now, we're just going to say, describe the trend. It's increasing, okay? And then we can even go one step further and say, okay, we can go, how much is it increasing every year? Okay? You can generalize that information by saying, okay, there's 4 years in this from 2002 to 2008. It looks like it went up $2,000 in about 6 years. So in that rate, it's going up about $500 every 2 years in 8 years. So about $500 increasing $100 per 2 years. Now, you can use that information to then make a prediction. Now that you know there's a general trend, you can say, okay, if this trend continues, I can predict the tuition cost. And you can see it's kind of already marked for you on the graph. And you can say, okay, well, if it continues on that same basic line of $500 for every 2 years, my last data is 2014. In that time frame from 14 to 820, it's about 4 years or 8 years. It's going to increase about another $2,000. So our prediction is going to, in 2020, we're going to see the cost will be about $12,000. And you could even do this all the way out to 2020, 2030 or 2032 when you'll be going to college. So about $12,000. And again, that's average, so there's obviously schools that are way more expensive and lower, and other schools that are lower. All right, now it's your turn. I want you to take a moment. I want you to look over the graph showing the weight of the kitten over several weeks, describe the trend, and then predict the kitten's weight at 18 weeks. All right, so let's look at the trend. Again, we have this general increasing trend. We have it pretty low here for the first 4 weeks. But after that, every 2 weeks, we get a pretty steady line right here. So we're going to go and use this as my increasing number. So in 2 weeks, the cat puts on pretty much that 7, 8, 8. So every 2 weeks, the cat puts on 8 ounces. So 8 ounces in 2 weeks, or you could say 4 ounces a week. Okay, if I want to say at the end of 18 weeks, what's my prediction? Well, it's week 10. There's 8 more weeks there. So we could do it off ours, 8 times 4, or we could do 2 times 8. It's 2 weeks, so there's 4 sets of 2 in there. So we're going to say the cat's going to roughly weigh about 64 ounces at 18 weeks old. Now, he might be more or above, but it gives us a general guess on what he might weigh. And it gives us, all right, is my cat healthy, that kind of stuff. All right, so let's go even deeper. What can the graph tell me about popularity of skateboarding? Well, we're going to look at even more in even more depth and look a little more deeply, specifically on this idea of the trend line and how to find it a little more scientifically. So we can definitely see that it's telling us the popularity is increasing, right? The popularity of skateboarding is definitely increasing. There we go. Excuse my spelling, apologies. All right, is increasing. Now, how can I tell how much? Because as a business owner or as the company for Sportsco, I need to be able to predict what's going to happen. And predictions mean I need to make the number of how many boards do I need to make next year? How much supplies do I need to buy? If I'm a store owner, how many skateboards should I keep in stock so that I'm able to have enough but not too many? Make some predictions based on that, not have to rush ship things and pay extra money in shipping costs. So one of the ways you can do that is you can look at, and we talked about this back with direct variation, we can look at the change in Y over the change in X. And really we're looking at slope here. And you'll talk and deal with slope in your pre-algebra class a little bit more. But what we do is we go, how much did it change from Y? So this one went from 2,500 all the way up to, let's say, 14, well, that's 400, so let's go 410. So 410 minus 250. So I see a change of about 160. And how far did it go? So it goes from 2012 back to 2006. So 12 minus 6, we get 6. So if I divide that, I'm going to do it on my calculator real quick so I don't have to think it out. 160 divided by 6. I'm going to see roughly a change of 26. I'm going to round up to 27 skateboards more a year. Now that could be in thousands, it could be in hundreds, but I want to be able to prepare for that and order more. If I'm the company, I got to make more so that I'm having 27 more skateboards a year ready to go for my customers. All right, your turn to go ahead and take a look at this one. Okay, I want you to look it over and do the same thing. What does the graph tell me about the popularity of bowling? Specifically telling me how much it's increasing pretty much year over year. All right. All right, so the graph shows the number of participants bowling from these 2 years. What does the graph tell me? Well, definitely the popularity of bowling increased, dipped a little bit, and then continued to increase. So guess what you're going to tell me? The popularity of bowling is generally increasing, because it is overall. And you can continue to tell me, but there was a dip or a drop around 1985. Okay, and then you can tell me, well, if I had to say a general increase, how much was it increasing generally? I'm going to say, well, it went up 30, and that's over 25 years. So the popularity increased about 1.2 million bowlers per year. All right. So we get a pretty good idea, and that's how you can explain what you see in a graph. All right, if you have questions, please feel free to reach out. I'd be happy to help. If not, I will see you the next time.